we now have come to an issue that he wants to talk to us about with regard to physics. Right?
Yeah, this one he titles The Current Crisis, but I think we've been in crisis as far as the public kind of perception of what science is. It's not that bleak of a plug and chug your numbers that we went over in the past couple chapters. But here we're going to take a look at kind of our reigning theories of the day, and we start with a look back at, well, what about the past theories? Was it just, well, the scientists of the day kind of went along and used what they could, but really knew that they didn't really have all the answers? Well, no. In fact, the history of it, at least where he starts with Newton, and so he provides this overview that says, for pretty much 2,000 years, science was done with this kind of Aristotelian model of things go up because that's the way that they were designed to. Things go down because that's
their nature.
Yeah, that's their nature. Yeah. That's something that's within itself that directs. And Newton comes along with his fancy calculus, or Leibniz, or really probably both of them at the same time. And
although I think Newton won, at least we give Newton the victory.
I mean,
right?
he's the Sir and the Sir Isaac Newton there. But he comes along and gives meaning to the chaotic behavior of physical objects in uncanny detail. So here comes Newton, and I mean, he had backings. In fact, his knighting is even a political maneuver by the Queen at the time to kind of curry favor. So his benefits for science is, I mean, huge. You can't touch on the history of thought, philosophy, science, really anything without acknowledging what Newton did as far as a revolution. Yeah,
part of the importance of it is how he attached mathematics to it, right?
Right, yeah, and we kind of same thing with Galileo. It seems, looking back on it, we go, oh well, all you had to do was drop an orange and a grape and go, well, they both fall at the same speed. Why wouldn't you just do that? Well, no, it's there's always kind of those defeaters that we talked about where you just it was the wind, or you drop the hammer and the bowling ball, and well, of course the bowling ball is going to hit because of the wind, but if we were able to do it on the moon, and then when we were able to go to the moon, we proved that Galileo was even right back then. So
that they fall at the same rate.
Right, exactly. Yeah. Yes, even at 1/6 the gravity. So during the 16th, 7th century, scientists even applied his physics, so much so that they thought it was the answer for almost everything, including things that aren't physical, that are physics, which are chemistry and biology. They really tried to factor in this mathematical approach, this new scientific approach that kind of Newton popularized, came up with, and turned about. So much so that Lord Kelvin, from 0 degrees Kelvin, which freezes all matter in the universe, announced that physics was complete.
How about
Look at that?
Yeah,
we
Newton
didn't have to
did
do
it. Right?
Any more work?
Yeah, Newton's deal was he was the end all and be all of physics. Right.
They were coming up with things. They were finding real answers, and real answers that were true. That it wasn't an approximation as far as they were. It worked. In fact, Newtonian mechanics is still taught, and we still think in Newtonian ways because of just how great it is. I mean, you really don't get into quantum mechanics and general relativity unless you're taking kind of third level physics in college. So, I mean, you even do Newtonian mechanics in college as well, until they pull the rug out from underneath you, until it's a different story. So Lord Kelvin here says, we pretty much got everything handled except for these, what he calls dark clouds on the horizon, things that, kind of muddled, but we'll get there. We'll eventually get there. We just need to, hone the math or come up with new technology. And so there again, what we talked about before is scientists have this really difficult approach of defeating their theories. They don't say, well, here are a few places where Newtonian mechanics seems to to
be
falter
strained.
it's hard. They really couch it in that kind of
but they don't give up the theory, right?
Right. They don't say, well, it's good enough for now, but we definitely know it's not true, especially because instrumentalism, it kind of comes at a later time, or at least has a wider acceptance at a later time. And so with this dark clouds on the horizon, it turned out to be exactly where quantum theory and relativity comes in and pretty much takes the knees out from underneath Newton.